let's get started and tell you everything there is to know about Firebolt. And I hope that by the end of this, you'll be as excited about Firebolt as we are. So, the Firebolt story begins with this slide. We're all about really shaking things up in the cloud data warehousing and data engine space. Firebolt is a new entrant. We emerged out of stealth earlier this year, and we primarily work with companies that are valuing data deeply, which means typically companies with a mature sort of data engineering mindset that have big data challenges, and for them we are here. So in the market, I want to sort of explain where we see ourselves. So we see ourselves as starting where the modern breed of cloud data warehouses and engines sort of end. If you look at this slide, the interesting part is sort of in the middle. Ever since Redshift came along, which we could call the first generation cloud data warehouse, which was very dramatic. Suddenly provisioning a new warehouse is a few clicks and not sort of how it used to be in the on-prem world. After that, we could maybe call Snowflake the second generation. They introduced this amazing concept of decoupled storage and compute, which the market favored, and the crazy IPO is maybe the evidence for that, and maybe we can call Athena and BigQuery a second and a half generation. They introduced sort of the concept of serverless warehouses and query engines. And each one of these technologies has its pros and cons. And the last 5 to 10 years, due to these technologies, definitely have been exciting because things have become so better for the users compared to the on-prem world. And this is why most of the on-prem vendors are seeing, customers transition to the cloud and adopting one of these technologies. However, if you're in the cloud using one of the modern technologies, that definitely doesn't mean that things are super simple suddenly. Mainly because the pace in which data increased has maybe outpaced the pace in which these technologies sort of introduce new innovations. And if you have a lot of data, if you're here, you probably already know that dealing with a lot of data in the cloud is far from easy. And Firebolt came to the market introducing something new. We're third generation cloud data warehouses, all about speed at scale. Firebolt can handle much more data compared to the others, much faster, while keeping things super simple to use and cost effective. And we'll talk about that in depth. Our differentiators are the following, and we'll spend time on each. So first of all, speed. Speed is something we're very proud of. We came into this market with a strong background in high performance databases. That's the core sort of DNA in our culture, in the background of our CEO, Boaz Farkash, who was a world known expert in that domain. And we typically start every POC by proving that we can deliver an order of magnitude faster performance over the workloads that you want to tackle. The second differentiator is scale. So from a scale perspective, it's not just that we're fast, it's easy to scale up and down with a few clicks, with the kind of elasticity that you expect from the modern cloud with decoupled storage and compute. And we'll talk about that as well. And lastly, it's about efficiency. So it's not, why is efficiency important? Because being fast doesn't matter if you can't afford it. Efficiency means being fast without relying on hardware that only NASA can afford. So we'll talk about that as well. All of these combined from product strategy perspective work together so that you can spend more time extracting value out of data, building out more use cases over data, spending less time worrying about configuration, tuning, the cost of the next query, and so forth. So let's start by talking about the speed differentiator. So just to sort of set the stage, if we were talking about the leading bunch, which is Redshift, BigQuery, Snowflake, the performance across these vendors is pretty comparable. If you look at the 5-trend benchmark, which I encourage you to Google, they update their benchmark every year. It's very clear there that already from the 1 terabyte scale, which is what they run the benchmark on, you can already see that query response time goes to 5 seconds, 10 seconds, and beyond. So it's very tough to deliver sort of a great interactive analytic experience if you go to that multi-second experience, and this is just 1 terabyte. So imagine what happens if it's dozens of terabytes and beyond. Firebolt can very easily deliver sub-second response times over these volumes. And I'll show you that literally. So let's switch to the product for a moment, to my web browser. And here we go. So now I'm going to show you the Firebolt product. But before that, we'll spend a minute or two on this Looker dashboard. So currently we're looking at the Looker dashboard, which is based on a real-world client of ours, which is connected to Firebolt. And it's actually running over 42 billion rows. I will click Clear Cache and refresh so you can see how fast it loads. So essentially, this is an ad tech use case. Here, it's completely refreshed. Comparing apps, clicks, impressions, and so forth. And the way people work with this dashboard is sort of account managers filter over specific media sources, which are their clients, and a variety of date ranges and so forth. So here you have, almost 3 weeks, 21 days in March for a particular media source. But I can actually show you that, if now I switch to a different media source, so I will paste another ID here. These are all garbled for presentation purpose. Then we will see that it refreshes with new data super quickly again. Or maybe I want to focus at the bottom here only on Android and not just on Android and iOS. So let's add Android to the filter. And click Run. And it's back with only Android. And just for triple checking, I will click Clear Cache and refresh. So you will see it's not a cache, but actually super quick. And voila, all the waiting indicators are gone. Now, let's see those same queries in the product in Firebolt so you can sort of have a look under the hood. So let's start by, I'm looking at this database called AdTechDB-v3, which is the one we use. Let's do a select star over the LTV table, which is the big fact table. And here we go. So we have 42 billion rows, not one row. And I'll open a query which I have here, which is the query that Looker generates. And you can see the following. So we have a with statement, a big select for looking at many fields from the big 42 billion row table. There's a bunch of a couple of left joins as well, and a variety of fields and aggregations, case statements, etc. And the where clause we saw before with the 3 weeks, etc. If I click Run, then we can see that we got a super fast response time, sub-second, which is, I would say, pretty impressive for 42 billion rows. We will come back to this example and I'll show you a little bit more, but let's go back to the presentation for a second so we can talk about how we do that under the hood. Where is the right screen? Hold on. Dear PowerPoint, where are you? Sorry about that, looking for my PowerPoint, which seems to be gone. Wait a second. Sorry about that. Zoom and the sharing features sometimes behave weirdly. Okay, here we go. So I want to introduce you to the concept we have under the hood from a technology perspective to give you sort of a glimpse into what's going on underneath. So, how do we make data, how do we make queries fast in the cloud when there's so much data? So essentially, you could look at our technology stack in a way that is bucketed at two different kinds of technologies. So the first bucket of technologies is more focused on the storage layer bottleneck. So the cloud is great because there's infinitely scalable storage. S3 is easy to scale, it's cheap, it's great for storing a lot of data, but it's also slow. If a query engine misses the cache and has to scan data in S3, things typically become too slow for interactive analytics. So the technologies handling that need to work on things like how do you store the data, how do you compress the data, how do you index the data, and how do you serve it to the higher memory tiers. A second set of technologies focuses more on the compute layer. This is where you deal with things like how do you squeeze the most juice out of the CPU, but particularly for analytic workloads, meaning aggregations, joins, group bys, etc. So in the storage layer bottleneck arena, a super important building block in Firebolt is our own proprietary file format, which is called FFF, or you can also pronounce it F3. When we pull data into Firebolt from your S3 or from your sources, we import it essentially in a converted way, and we convert it on the fly to this FFF format. And this format is a sorted format based on a primary index each table has. It's then also compressed super efficiently because sorted values compress better. And it's also indexed. And the type of index is called, academically speaking, a sparse index. That's a type of index that's very good at pointing to huge data sets, but remains small in size. So you can typically load it completely into RAM. And it works in a tightly coupled way with the file format. And what it does is something called pruning, data pruning. When a new query comes in, the index tells the query which very particular ranges of data, only the ones that actually participate in the query, to pull from the storage format. And what that does is that saves a lot of data movement. So typical slowdown in cloud query engines is that more data than the query actually needs keeps getting served from the lower memory tier to the higher ones. So for example, in Snowflake, a micropartition is the smallest piece of data that can move. With this indexing approach, we can literally bring sub-ranges of data, very granular and accurate runs. In itself, this plays a big role in the speed up. But not only that. So on top of that, we have the CPU-oriented technologies, like a cost-based optimizer, which turns human-written SQL into machine-optimized SQL. Vectorized processing is all about leveraging the columnar data structure and how it gets served to the CPU for maximum throughput, and how it leverages the CPU cache levels and many other great things, and just-in-time compilation. All of these things work hand in hand so that typically when you start working with Firebolt, very quickly you feel the speed. But we go a step further. We deal with customers who are sort of advanced in their data journey. And we really believe that you need to have the tools to accelerate and optimize further. So we give you, beyond sort of the index, for example, we talked about here, which is under the hood and you don't really know and feel it or sort of need to handle it. Also other types of indexes for you to use to accelerate things further. One example is a type of index called an aggregating index. An aggregating index is very good in use cases like reports and dashboards, use cases where you know in advance which dimensions and measures people will be playing around with. And in such scenarios, you can define an aggregating index. In this example, you can see, for example, that you predefine those game code, player code, currency code dimensions, and then any combinations of measures, including case statements that you might need. And what happens is that as data keeps flowing into Firebolt, it automatically gets added to the index. You never have to re-index it or worry about it or manage it, even if you resize your clusters. And when you run a query, the query engine can tell if the query is covered by an index. And if it is, two things happen. First, the query becomes even faster, typically sub-second, but it also becomes very light, sort of very non-straining on the CPU. So an index query is a very CPU light query, which means that you can typically even reduce your cluster sizes in these scenarios and save your spend on compute. So I'll go back to the product for a second. So if we go back here, I have pre-saved, I saved the index. So for example, for this data set, this was the command I actually used to create an aggregating index. You can see it on the LTV table. It has sort of the variety of case statements we saw before, and so forth. But that's not the only index. So for example, we have another type of index called the join index, which is particularly useful for accelerating joins and so forth. So with Firebolt, we really give you a variety of tools to work with to accelerate your queries and make them fly. That's something we deeply care about. Now, let's talk about scale. And to talk about scale, which I mentioned is our second differentiator, I want to do that through our architecture. So let's take a bird's eye view at the Firebolt architecture. Notice that the compute layer in the center and the storage layer at the bottom are decoupled. So to compare us architecturally to the market, we're, I would say, more similar architecture-wise to Snowflake than we are, for example, to BigQuery or Redshift. We really think that that approach of decoupling storage and compute is the right architecture for the future of data platforms. That's why we built ourselves the same way. At the bottom, you can see the data stored in F3 format, FFF format, to S3, persisted together with the indexes. In the Firebolt terminology, a compute resource, a cluster, is called the Firebolt engine. So you can see in the compute layer, there are a variety of Firebolt engines. And the way it works is that over one copy of the database, you can spin up as many such engines as you want. Each engine can be shared with different people, can be started and stopped at different times, can have a different size and different configuration, and in itself can be resized and changed with a few clicks. And at no point in time, you need to sort of migrate your data from engine A to engine B. Because of the decoupled storage and compute architecture, you don't need to move data, but you can run each query with a different kind of engine and cluster configuration. Firebolt is also fully SQL compliant. So you can see at the top the variety of clients that send SQL queries to Firebolt, whether it's through a REST API that powers a customer-facing chart or visualization in your application, or just your BI tools or JDBC drivers. Now, let's see how this elasticity and the decoupled storage and compute actually becomes something that's useful when you work with Firebolt. So again, I will switch back to the product. If we go back to this query we saw before, let's run it again for a second. So the nice thing is that I can dynamically choose a different engine to run this query on. So for example, I have this engine costs $3.8 an hour. I have here one that's actually dramatically cheaper. It might be a little bit slower. So yeah, from 0.28 seconds to 0.41 seconds, but I also paid much less. So you can literally at any point in time decide what hardware you're using. I can click the engines page here on the left, and you can see the variety of engines that I have in the system. Currently, Adds Query Fast and Adds Query Light are the ones attached to the database I just showed you. And when you work with engines, when you create a new engine, this is sort of the window you see. You choose a region, and you can choose the scale of the cluster, how many nodes participate in it. You can make it a spot instance to save some money on the compute. But you can also choose, and it's something very unique to Firebolt, literally the EC2 instance type that participates in the cluster. And the reason we believe that's very important is because oftentimes just increasing the cluster size is not the best solution. Every query sort of is bound by how much it can enjoy distribution across nodes. Oftentimes, just doubling the amount of RAM or SSD in a node of a cluster makes a huge difference in itself. Or working with a compute optimized cluster, which is in EC2 terms the machines that start with a C for compute optimized work differently than machines that start with an I, which are IO optimized, typically for faster network traffic. So for example, you see I have a predefined engine here called adds ingest. Typically, for example, when you want to move a lot of data, so for example, for this query here that creates the schema, the DDLs, the inserts of data into Firebolt, I would probably use a large cluster because in data movement, you can enjoy distribution. It works linearly very well. It costs much more because there's 16 nodes, but it moves data super quickly. So typically, in 10 minutes, I can move dozens of terabytes, and it costs me, $22 divided by 10 or by a 6, essentially, the proportion of 10 minutes in an hour. So that's the benefit of decoupled storage and compute, where we can literally, in a very dynamic way, run queries on different types of hardware. And so, for example, let's say you're an analyst building out a new use case. You could start by saying, hey, let's not use a monstrous and expensive engine. I will start by looking at a few days of data to validate my queries, that they are correct, that they return the right data. And you do that over maybe a very small and cheap cluster. And then you say, let's test it out on the entire data set that might be, 6 months. And for that, I need a little bit more horsepower. So I will switch to a cluster that's a little bit bigger, but I will only pay more for it now and not waste and not necessarily work on the strongest hardware at any given point in time. Okay, let's go back to the presentation. So to summarize what we saw in the product, being able to control the hardware is a core part of Firebolt, and we help you be granular about it. When you start off with our defaults, it works well, and then when you want to optimize further, you can literally choose the EC2 instance types, and then dynamically use it in the product. Now, I want to give you a few other examples that at scale make a difference. Things that are very easy at Firebolt. We call that rapid warehousing. So for starters, it's just scaling in general. What happens when as time goes by, your data doubles, quadruples, and so forth. Typically, that's good news, meaning maybe you're getting more customers, more traffic, and so forth. But as data grows, typically it becomes more challenging to keep things performant. So the nice thing about Firebolt is you never have to migrate to a stronger cluster. You essentially just move that slider that we saw before to increase the cluster size and suddenly be able to get more horsepower, more compute power for your analysis. And when you do that, you don't ever have to do things like recluster, reindex, vacuum, worry about partitions. Everything's handled behind the scenes. We call that sort of one-click elasticity. So you can focus on the important things and know that Firebolt will be able to scale with you. Another thing we love is seeing semi-structured data in use. So compared to a decade ago, semi-structured has become much more important for analysis because many more sources that we collect data from store data in a semi-structured way. And historically, it's been a challenge because data warehouses and databases have been built for relational data. So the typical approach has always been, let's flatten semi-structured data in advance in ETL processes, and then put it in the warehouse. And the downside there is that when you flatten the data, it explodes in size. So it's tougher to analyze and slow and expensive and so forth. Approaches that are more modern, and you can see that in BigQuery and in Snowflake, for example, allow you to ingest JSON as is into the warehouse, which is already a step forward because you don't have to pre-flatten. But then typically in the query runtime, you do a flatten command. So you flatten the data at the runtime of a query. The downside there is that it's very memory hungry. When you flatten in runtime, it still blows up the data, but in runtime, so it utilizes a lot of memory. So you can typically only analyze sort of smaller windows of time, and it's usually also slower. We do something very unique here in Firebolt. when we import JSON data, which we allow you to do as well, we convert it behind the scenes to a very efficient nested array structure. We also let you flatten in runtime, but we also expose a lambda-like syntax, which you can use in your SQL, somewhat similar to what you might have seen in Athena or Presto. And the lambda-like syntax is very flexible, super cool and efficient to work with that syntax over JSON, where you can tap into the nested fields very easily. And it's not memory hungry. So you can typically scale to a lot of data, semi-structured data in Firebolt and get the Firebolt speed. Another thing that we help you with are updates of data. So when you pump new data into a platform, every once in a while, you need to do updates as well. Updating is an annoying pain sometimes, because in warehouses in the cloud, when you update data, typically you have to recluster afterwards and replace big partitions. That is both lengthy in time and also CPU heavy and costs compute dollars. Our FFF file format is actually very good at being able to handle updates quickly and easily without the need for heavy repartitioning, reclustering afterwards. So that makes the process much easier and much smoother. And lastly, efficiency. So let's talk about efficiency for a second. We looked at the speed and we saw the decoupled storage and compute, and we talked about scale. But it wouldn't be worth much if you wouldn't be able to afford it. So efficiency is all about being able to do all that, but without hardware that's monstrous or huge. And this is where the technology kicks in, because the technology advantage in Firebolt means that you can do those fast things, but on less hardware. So do more with less. And that's thanks to the FFF file format, and thanks to the indexing, and thanks to all the sophisticated things we do under the hood to get the most out of the hardware. Part of that approach is also about letting you fine-tune as much as needed. We expose all the instance types for you to be granular in your optimization. Oftentimes, going for 2 nodes with a little bit more RAM is more cost effective than just going from 2 nodes to 4 nodes. So we let you do that. And we also let you use spot instances. So for your internal workloads, you can enjoy the AWS style discounts for spot. And we're also very transparent in our pricing model. It's a pay-as-you-go model. If you noticed before in the user interface, we always show you literally the price per hour of the resource that you're consuming. So it's a very straightforward and easy to understand pricing model, talks in AWS terms, compute, storage, etc. And I think this is it. This is Firebolt in a nutshell. Thank you for joining us. I hope that makes things a little bit clearer now. Follow us on LinkedIn to sort of stay up to date.
Hang on. Before we leave, there's a ton of questions, so let's try and answer as many of them as we can. But
just
before we get there, we've got the last poll question for the day. So let's fire that up. Okay. Are you ready? Would you like to check out Firebolt? So look, seriously, if you do want to see Firebolt in action and understand whether it's relevant for your own use case, then just select the right option, and yeah, we'll be in touch. But now let's move over to some of the questions we have. I don't think we'll be able to answer all of them live, so we'll get back to you offline. But I see many people are asking if they're going to get the recording. So yes, you will get the recording. Rest assured. Is Firebolt available on Azure and GCP? No, it's not, and it's not going to be available, for the foreseeable future. Is Firebolt fully ANSI SQL? Yes, it is. Is there a trial environment I can access? Boaz, I'll let you take this one.
Yeah, so good question. So Firebolt, Being a new entrant vendor in the market, we don't have a self-service trial environment for everybody in the world to sign up and use yet. Um, Probably a little bit into next year. But what we do at this point is, first of all, if you're interested in trying us out, let us know, register, sign up, and we'll have a conversation and try to start a POC. So we're a little bit more selective in who we work with at this point. We're looking for use cases where there is a real data challenge. And what we do is typically is we connect you to the our listing in the AWS marketplace, and we ask you for access to your data and a few examples of workloads and queries that you're running or dashboards and so forth. And we bring our solution architect to sort of show you how we do that in Firebolt and show you how we put the indexes in place and show you how we can get great performance and with hardware and with which kind of hardware. And after we do that, we give you the keys to play around and extend it further yourself. So please do sign up. Let us know. Would be super, super more than happy to show you Firebolt in action.
Cool. Now there's there's about 50 questions here, so I'll let you just go through them. And
I see here.
Can we run Spark on Firebolt tables? That's an interesting one.
Can we run Spark on Firebolt tables? So it's a good and interesting question. So you cannot run Spark directly on Firebolt tables. However, we have done and are doing many Spark sort of replacement jobs. What does that mean? We're not a Spark replacement, but rather warehouses these days that enjoy decoupled storage and compute are great at ELT. This means that instead of transforming data in advance and then putting it in the warehouse, you can use a cluster in Firebolt and do the transformations in Firebolt. So for example, in an ELT setting, in a Spark replacement setting, we've oftentimes taken a Spark job that takes like an hour or 50 minutes to run and replaced it with a job that takes a minute and less to run. Now, Spark does a lot of things, machine learning and Python, and really it's a great tool to do a lot of stuff. But when you use it for sort of analytics preparation, meaning aggregating data, denormalizing data, and so forth, and you can express that in SQL, then we feel it's the much better choice to actually run that job in Firebolt and save a lot of money on compute because the jobs run much faster.
Mm-hmm. There's a few questions regarding our pricing model. Do you want to elaborate on that?
Yes, so we have a pay-as-you-go model, so it's easy to start with. Essentially, when you choose the hardware through our user interface, we essentially show you the EC2 instances, but we have our own price for them. And this is where we make our profit, sort of compared to the original AWS price. But the big cost savings in Firebolt come from the efficiency, meaning that you can do more with clusters that are typically much smaller, and this is where you save costs. So we typically show like up to easily can get up to extent cost savings, and that's also something we focus on in the POCs, not just showing you the speed, but showing you which hardware it runs on, and then working together to help you calculate how much that can cost you if you run it on a monthly basis and so forth.
Is Firebolt cloud only or also available as a hybrid option?
No, so Firebolt is SaaS only, meaning that data is copied outside of your VPC. But the way it works is, I would maybe reshare a slide for a second. Yeah, so the way it works, if we go back to the architecture slide, so we integrate through the AWS Marketplace to your account where you spin up a dedicated account, Firebolt account for you. For every customer, we have an isolated sub-account on AWS. Essentially, the compute and storage layers sit in an isolated AWS sub-account managed by us, to which your data is copied. But it does leave your VPC. But it also enjoys isolation, which is good and typically can pass most of the security conversations pretty easily.
Okay. So look, there's plenty of others. I don't think we're going to get through all of those now, but we will be getting back to each and every one of you. Rest assured.
I wait
So
a
thank you
second.
for
I see
joining us.
questions. I see a question here I'd
Yeah.
actually like to answer. Somebody asked, compared to Snowflake and Databricks, the architecture looks similar. What's our advantage or unique selling point? So compared to Snowflake, the first difference is speed. And we saw it in the 5-trend benchmark, meaning in Snowflake and also with the others, once you are in the hundreds of gigabytes and the 1 terabyte, and of course beyond, it's very difficult to make queries go below 5 seconds, especially if you want to keep costs down. So Snowflake will encourage you very quickly to go to stronger clusters, spend more money on more compute, and it will not. And sometimes it will work, but oftentimes that won't work either. So it's much easier to get much more performance out of Firebolt without the hardware. And in Firebolt, you also get more control. So our approach in general is to give you a little bit more control, be more granular in your hardware choices, enjoy spot instances, and so forth. And semi-structured in particular, also something that we do amazingly well. Databricks is a little bit different. So Databricks, it's based on Spark. It's much better than Snowflake and also than Firebolt in sort of batch processing and then machine learning Spark job and so forth. But it's much less effective as a high performance query engine and it's slow. That's it, I think. Anything else I missed, Asaf?
Well, there's plenty, but again, we don't have time for all of those. So thank you, everyone, for joining us. Hope you enjoyed the session. And yeah, follow us on LinkedIn, to keep up to date on what's going on at Firebolt. And that's it. Have a great rest of your day. Thank you, Boaz.
Thank you.
Bye, everyone.